Welcome back. You're with us on Overdrive. I'm sure you and I both have struggled at some point of time with tight parking spots or even taking U-turns in narrow streets. Well, ZF's new EasyTurn promises to make things very easy for us. Let's take a look.
With the wheel on this i3 sticking out so much, you might think it's actually broken. Well, it's not. It's the beauty of ZF's new tech, which they like to call Easy Drive. With that kind of articulation, with that kind of turning, they're able to give you a much easier maneuverability and easy parking, especially in tight spaces, which is pretty much everywhere in India. Let's take a look what this is all about.
The ZF EasyTurn aims to enhance driving efficiency in urban spaces and is compatible with electric cars and widely used McPherson axle systems.
Now, this is a BMW i3. It has a turning radius of 10 meters. However, with this, it's 7 meters. So, what they've essentially done is, on the front wheels, it's using a McPherson strut, like we always know. But in this kind of a tight maneuver, you will see that the car can easily finish a complete U-turn maneuver. This is unreal. In such a tight space, the i3 just took that turn so easily. So how have they done this?
In a nutshell, the car is able to achieve this because ZF's tech can achieve a steering angle of up to 80 degrees, as long as the car makers are able to design wheel arches deep enough to accommodate that level of wheel turning. The ZF EasyTurn can be employed or integrated quite easily.
So front wheel driven cars, which we have traditionally driven for the longest time in India, it's not going to work with that. So that's the only limiting factor. But with every car maker now looking to create city-friendly, easy-to-drive EVs, which are primarily rear-wheel driven if they are running a single motor setup, this kind of an arrangement is easy to integrate. Of course, if you have in-wheel motors, again, this arrangement is easy to integrate. And of course, ZF works with OEMs to make sure that all of this is fine-tuned, the steering ratios are fine-tuned, the tuning of the steering, the tuning of the software is all done as per the vehicle's need and target. So I think from that perspective, all of this is simply superb. So you can see it is still 2.5 turns lock to lock. So what that essentially means is it's not going to be any different than your standard car as far as the learning curve is concerned. The learning curve is going to remain the same. In fact, at 45 degrees, which is ideally what you turn when you are in a panic situation, when you probably want to avoid something on the road, or maybe you suddenly see a diversion and you hit that, 45 degrees is what you usually hit on the steering wheel. And up to those 45 degrees, it's still going to behave almost the same way as a traditional car with McPherson struts. So even though the wheels turn so much, you're never really going to get into a panic situation where you have turned the wheel so much and then the vehicle is going to topple over. 45 degrees is usually what you do. You're never really going to go 2.5 locks, so that's definitely not going to happen. So even from a safety standpoint, it's not that big a deal. They've got it all covered. Now, this is very similar to a McPherson strut setup that we've seen on traditional cars. But compared to that traditional setup, they have 2 additional links. So essentially, what that means is, it's just 2 extra links worth of hardware, 2 extra links worth of metal. So in terms of the costs, that's not much because, it's not running any fancy electronics, it's not needing any fancy semiconductors, any additional hardware, any additional software. It's just these 2 links. The geometry is what makes all the difference there. The calculation as per the vehicle is what makes all the difference there. So what I'm coming to is, with just this much extra metal required, if car makers can easily manage their economies of scale, integrating this technology, even in sub-4 meter vehicles, shouldn't be that much of a problem. The only challenge is that it only works with rear-wheel driven cars or on axles that are dead. No live axles here. And what happens when you pair this tech with rear-wheel steering? You get crab walk, something that the internet is going crazy about. Let's take a look. So what does this mean in the real world? Well, I think this technology is going to find a lot of applications with the commercial vehicles, because those guys are always scrambling for space, right? They're always contending with tight spaces with their big commercial vehicles. But so are you and I. With all the tight parking spots, all the traffic jams, this tech could make a lot of sense to people like us. However, like I said, the biggest challenge is that it cannot be integrated with a live axle or with a front wheel drive setup. You have to be a rear wheel drive car and then you can put it in the front, which means that our traditional hatchbacks, ICE, it's not going to work with that. But maybe in the future, if we start getting a lot of electric vehicles even in the hatchback space, this technology is economic enough or it is accessible enough to be integrated even in low-cost vehicles. So low-cost EVs could find this tech to be a boon, something that can be a boon for you and I. So I really hope this technology is something that we see in the future on the road soon.
With that, it's a wrap on this week's edition of Overdrive. But remember, you can stay in touch with the team through our various social media platforms, and you can write to us on YouTube as well. We'll see you next week. Until then, goodbye. Drive and ride safe.